Whether you are a machinist working on small precision parts or a factory cutting holes into heavy steel, a drill is one of the machines you come back to again and again. For more than a century, builders around the world have developed remarkable drilling machines, from ordinary shop drill presses to massive radial drills and Swiss precision machines where making a hole becomes an exercise in measurement itself. As always, make sure to like and subscribe before we count down the 20 greatest drilling machines ever built. We begin with the Delta 17600. It is probably the closest machine to what most people picture when they hear the words drill press: a round column, an adjustable table, a belt-driven head, and a hand-fed quill. Delta 17-inch drill presses had been working in American shops since the late 1940s. One machine with a 1949 serial number was recorded as having spent many years in a production facility. Its previous owner said he had started running it when he was just 13 years old. In 1950, this type of machine sold for around $180 to $196 depending on the options. Not cheap for a shop machine at the time. The fact that many of them still survive with their original head, table, and column after more than 7 decades says more about the design than any advertisement ever could. What kept these machines alive was not some exotic mechanism. It was the way the fundamentals were made: a substantial column, a long quill, a Morse taper spindle, and castings far heavier than many modern consumer machines. The limitations are just as clear. Speeds are changed by pulleys, feed is entirely by hand, and the table offers no coordinate positioning. It takes the 20th position because it is the baseline of this list. A traditional drill press, built well, genuinely industrial, and extremely durable. But it does not yet solve the problems the machines above it were designed to address. Walker Turner began in the late 1920s in New Jersey, building smaller machines for home shops and light industry. The company grew, was acquired by Kearney and Trecker in 1948, and later came under Rockwell in 1956. The Walker Turner machines carrying the Rockwell name belong to the final chapter of a line that passed through several owners. The brand disappeared, but the machines are still restored today. One reason Walker Turner's reputation is larger than the number of surviving machines you actually see on the market. The 20-inch 7400 series is notable because some production versions were equipped with power feed. One restored example retained its production table, a 1-horsepower 3-phase motor, and its original power feed mechanism. The restorer described it as one of the finest drill presses ever built. Power feed mattered because it turned feed rate from a matter of hand pressure into a repeatable motion. In short-run production, that is the difference between a good drill press and a machine capable of making hundreds of holes with the same approach. Many surviving examples have had motors, chucks, or even parts of the spindle replaced, so the condition of the individual machine matters more than the badge on the front. It earns this position because it adds a real production feature to the Delta formula, but it remains a conventional upright drill press with many of the same structural limits. Next comes Buffalo Forge, a company better known for forges and industrial equipment. But the number 18 line shows that Buffalo saw drilling not simply as a single standing machine, but as a production problem. The number 18 came in a wide range of configurations: floor models, bench models, foot feed machines, production tables, and versions with 1 spindle all the way up to 6. There were also reversing models for tapping. Some production versions weighed more than 500 pounds, showing that Buffalo treated this as production equipment, not a bench accessory. The Model A even used foot feed with automatic controls, allowing the operator to keep both hands on the workpiece. The most memorable feature is not a single RPM figure. It is the way Buffalo could turn one platform into a 6-spindle line. If a part needed several repeated holes, the shop did not have to move one spindle over and over again. It could arrange multiple drilling heads to work in parallel. It was automation in cast iron, gears, and fixtures before CNC existed. Today, that variety makes restoration more complicated because parts do not always interchange between versions. Its importance lies in its production logic. It did more than a simple drill press, although it still did not transform how the spindle was driven or how hole location was established. Crossing the Atlantic to Britain, we find the Fabco 10-8, a machine whose reputation is much larger than the size of the company behind it. After the war, many British workshops had to shift from military production back to civilian work, and drill presses were one of the products that made good use of existing machining capacity. F.O. O'Brien developed the Fabco drills after the family business had worked in subcontract machining, and the company kept almost the same basic machine philosophy for decades. The 10-8 was the heavier version, using a No. 3 Morse taper spindle and a speed range that could drop to around 50 RPM and climb above 2,600. That allowed it to handle everything from smaller drills to larger tooling that many machines of similar size did not manage comfortably. One interesting detail is that Fabco once did subcontract work for progress drills, the rival that appears in the very next position. Two names often compared by British users were, at one point, directly connected through production history. The 10-8 did not have sophisticated power feed, a coordinate table, or serious production capacity. What it offered was an impressive working range in a small footprint, but it remained a much simpler machine than the geared drills above it, and it still could not match the next machine on the list. The Progress 2GS is one of the British drills remembered for one very specific thing. It could run slowly, properly slowly. Engage the back gear, and the spindle drops into the range of only a few dozen revolutions per minute. That matters more than top speed, because a large drill needs torque and low RPM, not a 4,000 RPM figure printed on a brochure. Progress was also one of the representative machines of Britain's post-war market, where small shops needed compact machines capable of jobs that had once required something larger. The 2G and 2GS machines still survive on the used market because they occupied the right middle ground between a light bench drill and a heavy production machine. That same environment is where Fabco, from the previous block, became a direct competitor. The downside was that the operator still had to select pulleys and gears manually, and the gearbox made the machine more complex than an ordinary step pulley drill. It ranks here because this is the first machine on the list where the drive system truly expands cutting capability rather than merely making the machine more convenient to operate. The first drilling machines associated with Meddings appeared during the Second World War under the Passera name. Britain needed large numbers of simple, reliable machines for training, maintenance, and wartime production, exactly the kind of environment that creates a drill press that must be easy to use and hard to destroy. After the war, the company expanded its product line, and Meddings drills became a familiar sight in technical schools, maintenance departments, and tool rooms across Britain. The MF4 represents that philosophy. It was not enormous, but it had both a low range for larger drills and a high range for smaller work. Some configurations ran from around 80 RPM up to 4,000. What matters most is the life of the idea. Meddings did not try to compete directly with heavy radial drills. Instead, the company focused on small and medium pillar drills, refining them across generations. It lacks the mass, feed system, and cutting power of the machines above it, but it is one of the most common drills to encounter in older British workshops. It is one of the best balanced smaller pillar drills, more flexible than the Progress at the high-speed end, but not yet in the heavy-duty class of AV and Arboga. The AV Drilling Machine Company had been active in the Cincinnati area since at least the early 20th century. By 1919, the company had produced more than 8,000 machines, and by 1929, its serial numbers had passed 15,000. AV also filed several patents related to belt drives and feed mechanisms during the 1920s. The U.S. government's 1941 machine tool price schedule still listed a wide range of AV equipment, from bench drills to multi-spindle column machines, showing that the company had been deeply involved in production drilling for decades before the BMA-6. The BMA-6 is one of the clearest examples of how AV thought about machines. A spindle that was not especially large, mounted in a structure weighing more than a ton. A machine like that did not exist because the company lacked the ability to make it lighter. The mass was there to resist movement in the head and table when the drill was under load. Other AV machines were also used in industrial training. A double-spindle AV in Colombia was recorded as having entered a technical school in 1955, where it served in heavy drilling work. The weakness is obvious. It takes space, requires rigging, and is far more machine than most small jobs require. The BMA-6 ranks 14th because it buys stiffness with mass better than the pillar drills below it, but it still lacks the geared head and operating convenience of the Arboga above it. Next comes a drilling machine from Sweden. Arboga began building drilling machines in 1932. Instead of relying mainly on pulleys, many of the company's models used enclosed geared heads, a feature that became one of the signatures of Scandinavian drills. The A2608 used an MT3 spindle, offered a drilling capacity of roughly 25 millimeters, and provided 8 mechanical speeds. The A2608M added power feed, moving the same platform from maintenance work toward light production. An enclosed geared drive offered 2 practical advantages. The operator did not have to move belts every time a speed changed, and spindle speed did not depend on belt tension. This was the kind of machine that made sense in a shop where many operators shared the same drill. Arboga and related brands were later brought together under Machinery Scandinavia, and the Swedish geared head drill concept continued into modern production. That is a rare lineage. Motors, guards, and controls changed over time, but the basic idea of an enclosed gearbox hardly needed replacing. The drawback is that when the gearbox has problems, repair is more difficult than on a simple belt drive machine. The A2608 ranks 13th because it combines compact size, geared drive, and a power feed option better than traditional pillar drills, but it does not yet offer the modern capability and range of Flott or Alsmetall. At number 12 is Flott, one of the German manufacturers that kept the upright drill press alive into the CNC era. The SB30 Plus does not try to become a machining center. It keeps the familiar form, but removes many of the manual steps older machines forced the operator to accept. The machine uses an MT3 spindle, has a drilling capacity of around 30 millimeters, and offers variable speed. Plus versions can include speed display, depth display, tapping, and feed depending on the configuration. The important point is not one specific production year. It is the fact that Flott continued developing the pillar drill as a modern product line at a time when many Western manufacturers had abandoned the segment or moved to imports. The SB30, therefore, represents a branch of machine tool history that did not die. The dedicated drill press still exists alongside CNC when the work does not require a machining center. It is easier to operate than a Progress, Meddings, or Arboga, but its electronics also make long-term repair more dependent on specific components. The SB30 Plus is one of the most complete modern drill presses built on the classic formula, but it still prioritizes usability over truly heavy drilling capacity. Alsmetall was founded in 1945 and began building drilling machines in 1947. The speed of its growth was remarkable. Its 10,000th drill left the factory in 1956, and by the end of the 1960s, total production had passed 50,000. Its customers were not only small workshops. The company's history includes Deutsche Bundesbahn and automotive manufacturers among its buyers. The AB4 SV sits firmly in that heavy-duty tradition, an MT4 spindle, a drilling capacity of roughly 40 millimeters, and low-speed ranges suited to large tooling. This was a machine built to handle torque, not to compete for the highest top speed. By the late 1970s, Alsmetall had become one of the leading drilling machine manufacturers in Europe, producing hundreds of drills each month. By the mid-1980s, total machine deliveries had exceeded 80,000. The weakness of the AB4 SV is that small, high-speed work is not its strength. This is the first pillar drill on the list, with both a massive production history and genuine heavy drilling ability. But it still is not as flexible as the Ellis in the next position. Returning to the United States, Ellis Manufacturing was founded in Wisconsin in 1950 by D.R. Ellis and his two sons. The company initially built agricultural equipment, then moved into band saws, belt grinders, and eventually added drill presses to its product line. The 9400, then, did not come from a giant machine tool corporation. It came from a family company that still uses its own machines in its factory to build other products. The 9400 offers variable speed, power downfeed, and electronic reversing for tapping. Its most valuable quality is torque at low speed, which suits fabrication shops where large drills and tapping often matter more than high RPM. Ellis still produces the 9400 in the United States, and continues to revise the machine based on how it is used inside its own factory. That is a rare detail in this list. The manufacturer does not merely sell the drill press, it uses the product every day to build other machines. Its weakness is the upper speed range, around 1200 RPM, which is not ideal for very small drills. The 9400 ranks 10th because it combines modern operating convenience with a simple heavy-duty foundation, but it does not quite reach number 9 because it lacks the mass and variable drive reputation of the Powermatic. The Powermatic 1200 appeared at least as early as the 1960s and quickly became one of the most recognizable American industrial drill presses. Two mid-1960s examples once appeared together in a factory liquidation decades later, an image that fits the machine's reputation perfectly. Old production machines kept in service until the facility itself closed. Some 1966 machines have continued to appear in plant liquidations many decades after they were built. The Model 1200 weighs around 500 pounds, has more than 6 inches of quill travel, and uses dial-controlled variable speed. Instead of opening the cover and moving a belt to a different pulley step, the operator adjusts a sheave system to change the drive ratio continuously. It is the kind of improvement that is easy to underestimate until you spend a day drilling many different hole sizes. Speed becomes something you set for the job, not a separate setup process. But the Reeves-style variable drive is also the machine's best-known maintenance issue. The sheaves, belt, and sliding mechanism must be in good condition if the machine is to work as designed. The Powermatic 1200 ranks 9th because it brought variable speed to a heavy-duty drill press in a very convincing way, but the closing above it offered a more complete head, spindle, and production package. Clausing's lineage reaches back to Atlas Press in 1911, a company born to serve America's rapidly expanding manufacturing sector. More than a century later, Clausing still sells 20-inch drill presses in the United States, a rare survival for a traditional machine line. The 2276 is the result of that philosophy. It has variable speed, an MT3 spindle, long quill travel, a 4-inch column, and power feed variants. Just as important, Clausing still offers the 2276 in its current catalog, unusual for a drill press whose basic form factor has changed so little across generations. Its real strength is the balance between capacity, footprint, and support. While many machines on this list exist only through auctions and old manuals, the 2276 is still a current model. That means a classic industrial drill press design remains useful enough to survive in the age of machining centers. It will not drill enormous castings, and it will not locate holes like a jig borer, but it may be the most complete upright drill press on this list, strong enough, flexible enough, still supported. From this point upward, however, the machines begin solving problems that a pillar drill cannot. The name Hole Wizard sounds like advertising, but this type of machine existed because of a very simple problem. Some castings are too large to place on the table of a drill press. A large American Hole Wizard used a radial arm several feet long, a heavy Morse taper spindle, power elevation, and clamping. The operator brought the head to the workpiece instead of bringing the workpiece to the head. Machines like this were once common in tooling and heavy industry, especially in shops handling plate, dies, and repair work before large CNC machining centers became common. One person who spent more than 30 years in tooling described the radial drill as an extremely fast machine once the rhythm was established. Stack the plate, clamp it, drill a series of holes, then slide the next workpiece into position. Hole Wizard machines still appear today in the equipment lists of repair and heavy machining shops. The limitation is built into the radial arm itself. The more movement available for setup, the more places there are for wear and loss of stiffness. The Hole Wizard ranks 7th because it opens an entirely different kind of work, drilling on parts too large to move easily, but the Carlton above it solved the radial drill problem in a more refined way. Carlton did not simply manufacture radial drills. The company repeatedly patented the most difficult parts of the machine. Jack C. Carlton filed a radial drill patent in 1924. Later came patents related to transmissions, and by 1931, a clamping mechanism. The clamp patent was granted in 1935, showing that what sounds like a secondary issue, locking the arm and head, was important enough for the company to spend years developing it. That says exactly where Carlton's attention was focused, making the head easy to move during setup, yet rigid when cutting. The Model 3A expressed that philosophy through power arm elevation, power head traverse, power clamping, and dozens of spindle speeds. On a large machine, the operator could move from pilot drilling to reaming, tapping, or large drilling without needing a separate machine. The downside is that a Carlton with wear in the arm or clamping system may look impressive, but no longer hold its original geometry, and restoring one is not cheap. It is one of the most complete mechanical radial drills ever built. Ranking above Carlton is Cincinnati-Bickford. Its drilling machine line can trace its history back to 1874. By 1941, the official U.S. government price schedule listed a full range of super service upright and radial drills. That places the super service directly in the period when the United States was preparing for the massive industrial expansion of the Second World War. By the late 1940s, the company's advertising still claimed that metal drilling machines had been its exclusive product since 1874. The super service existed in many sizes. A 4x11 machine weighed around 11,500 pounds. Larger models could exceed 20,000 pounds. Some offered as many as 36 spindle speeds and 18 feeds. These machines were built for shipyards, heavy equipment plants, and factories where the workpiece was too large to move around the shop. The weight and gearboxes were not decoration. They allowed a long arm to work under serious load. The price was size, rigging, and wear in the radial system. This is the peak of the heavy radial drill. Long production history, enormous capacity, and a broad working range. But from this point upward, the machines must answer a different question. Exactly where is the hole? The first machine in the top four is the Aciera Type 22. The Swiss company built it not as a single model, but as a family. Manuals for the line exist in English, French, and German, reflecting the broad European market Aciera targeted for precision drilling and tool room work. There were bench machines, floor models, multi-head configurations, and versions that Aciera itself described as coordinate drilling, tapping, and boring machines, or even semi-jig boring machines. The 22VA belongs to that family. It has a coordinate table, variable speed, and enough capability for drilling, boring, tapping, and light milling. The important point is how Aciera expanded the same general head and base into so many configurations. Instead of buying a drill only to make holes, a tool room could own a machine that lived somewhere between a drill press and a jig borer. Its absolute capacity is not large. A radial drill lower on this list could handle much larger holes. The Aciera 22VA ranks fourth because it changes the criteria of the list. For the first time, the relative position between holes becomes the main reason to buy the machine, not the maximum diameter it can drill. Fahlman was founded in Switzerland in 1930 and initially built drills and smaller workshop equipment. A major turning point came in 1958 when the company introduced the TB13C with a coordinate table and the P18 precision coordinate drilling and milling machine. That lineage leads directly to the Picomax. In 1975, Fahlman brought the Picomax 50NC to the EMO exhibition in Paris, the company's first NC machine and, according to Fahlman's own history, a product that attracted significant attention at the show. That line continued to be revised and built until around 1993. Later, Picomax models were produced in large numbers and made the name synonymous with precision and handiness in many European tool rooms. The Picomax 20 sits on the more manual side of the same philosophy. The operator still feels the quill and controls the machine directly, but the coordinate table and measuring system remove much of the error from setup. It is not a CNC machining center, and that is exactly part of its appeal. The Picomax ranks third because it is one of the best bridges between the manual drill mill and modern coordinate machining. But the two machines above it were built around positional accuracy at an even higher level. At number 2 is a name deeply respected in the American machining world, the Moore number 3 jig borer. In 1932, Moore's special tool could not achieve the die tolerances required by the clock shops and brass shops of Connecticut's Naugatuck Valley using the equipment available at the time. So the company built its own jig borer using hardened, ground, and lapped lead screws instead of softer screws compensated for error. By 1950, Moore had sold more than 1,500 number 1 jig borers and around 500 jig grinders. The number 2 design, after its introduction, also quickly reached hundreds of machines. That was a significant output for a tool-room precision machine. In 1955, the number 3 appeared as a more accurate generation. The important point was not horsepower. A jig borer served jigs, dies, and gauges. If a production part is wrong, you lose one part. If a jig is wrong, the same error can be multiplied across thousands of parts. Moore also invented the jig grinder in 1940 to solve the next problem. A part jig bored while soft could distort after heat treatment, so the hole had to be ground back to its correct location after hardening. The number 3 takes the runner-up position because it made hole location the true product of the machine and changed how tool rooms thought about drilling. It loses the top spot only because SIP took that same problem into an optical measuring system more independent of the lead screw. The champion of today's list comes from one of the world capitals of precision, the Swiss-built SIP Hydroptic 6A. SIP was founded in Geneva in 1862 to build scientific apparatus and precision measuring instruments. Before it made machine tools, the company produced working standards for major metrology organizations in Europe and the United States. Between 1919 and 1921, SIP began moving into jig boring. A very early MP5 was delivered to the Royal Small Arms Factory at Enfield in 1922, proof that this type of machine almost immediately entered precision defense work. In 1934, the Hydroptic appeared with an idea different from Moore's. Instead of deriving position only from a feed screw, the machine used a standard scale read through an optical display. The table was also moved hydraulically, giving smoother motion. The system was so successful that the Hydroptic became one of the most famous jig borers in the world. In the late 1950s, the 6A developed from the number 6 with a more powerful spindle and greater travel. A typical 6A had a table more than a meter long, drilling capacity of around 55 millimeters, and a weight of roughly 7.5 tons. This is the payoff of the entire list. Delta made the quill better. Progress added gearing. Clausing perfected the upright drill press. Radial drills brought the spindle to the workpiece. Moore turned the lead screw into a measuring standard. SIP placed an optical measuring standard inside the machine itself. The Hydroptic 6A takes first place because it did not merely make good holes. Its entire design was built around knowing exactly where that hole was. That is the farthest the idea of a drilling machine could travel before merging into the world of coordinate measuring and CNC. If you need a traditional drill press for everyday use, the Clausing 2276 may be the most complete choice on this list. If the workpiece is too large to bring to the spindle, the Cincinnati-Bickford Super Service wins. If you want a flexible tool room machine, the Picomax makes more sense than either. And if the question is mechanical precision alone, the Moore number 3 may be the most respected machine here. But for absolute positional accuracy, we arrive at the SIP Hydroptic 6A. A hole sounds simple until it must be the right diameter, the right depth, square to the surface, and in exactly the right location, so another part still fits. Which machine would you put at number 1? Clausing, Cincinnati-Bickford, Moore, SIP, or something else entirely? Let us know in the comments, and tell us the name of the drilling machine you use in your own shop. And if you enjoy stories about the machines that helped create everything else, subscribe to the Gear Archive. We'll see you in the next episode.